My name is Jack, and today I'll be discussing the Haus problem, the mathematical model I've used for the problem, the simplex code I've got from that model, and the solutions I've found to the problem. The problem details Mr. House building a home and enlisting 25 friends to help. Multiple tasks are required, such as masonry, heating, and plumbing, and different friends are qualified to do different tasks, and each friend is willing to work for a one-off amount in thousands of dollars. The cost of each friend to work and their qualified skills is displayed below. The model to find the minimal cost that Mr. House can spend to get all the required tasks done is found below, with letting xi be the ith friend to work. There must be one friend qualified to complete each task, such as moving the windows in the garage. So the below constraints were used, each task is completed. The below simplex code defines all the decision variables as Boolean values, so binomial, 0 or 1 because it's either the friend is used, representing 1, or not, representing 0, and then the minimal cost for the problem is represented by the float cost equation in the top right. And then because each constraint, so each job needs to be done, they're represented by the below constraints that were written out before. This is just the actual simplex code that was used. So the optimal solution found is that friends 1, 3, 14, 15, 16, and 25 are selected to do the work for Mr. House, and the total cost that he will need to pay is $130,000. So 2 additional constraints were required to add. One being that friend 15 and friend 16 are both hired if and only if friend 25 is hired. That's represented by constraint 16 and 17 listed below. And then there was a constraint that friend 3 was hired, then only one of 16 and 25 can be hired, represented by constraints 18 and 19 below. And then because to make the if constraints usable for simplex, we needed to add a decision variable constraint for y, which is also listed. So with those additional constraints, it was found that friends 1, 13, 15, 16, and 25 were used, and that the optimal solution was $140,000 in cost, so the constraints did add additional $10,000 to the cost. Then lastly, we were asked to find the minimal number of friends that could be used to complete the job, which did require to change the model of the problem. So the updated minimization problem is there, with obviously no cost for each friend, just if they will be used or not. And with the updated model, we find that the minimum amount of friends can be used is 5, which is friends 1, 3, 15, 16, and 25. And so Mr. House using 4 friends is not possible because not all constraints will be met.